Perfect.
Yep.
Yeah, so I'm Dan Laney. I'm from Lawrence Livermore National Laboratory. I'm presenting the ExaWorks project. It's an ECP workflow project with Dong Ong, Kyle, and Shantanu Jha from Brookhaven. But I think Rutgers is also an affiliation. So I wanted to say a few words about the ECP. It's a huge project. In case folks weren't aware, it's in the Department of Energy. It's managed out of the science, the open science side, but it actually encompasses both the National Nuclear Security Agency part of the DOE, which is the nuclear weapons sort of complex. And there are three labs there, Lawrence Livermore, Sandia, and Los Alamos, that perform basically the scientific functions of that program. And then there's a huge number of other, manufacturing facilities and things like that. And then the Office of Science Labs, which do a lot of the open science research. And so this project is basically centered around three different things. The first is deploying applications to exascale hardware, and there are several dozen applications being funded, and all across many areas of science, oftentimes coupling together very complicated individual pieces that have been built by research groups at universities and in concert with the Department of Energy. There's a software technology stack, which is where ExaWorks is located, and that's trying to build a software stack for exascale computing and produce a bunch of software development kits for doing very large scale computing and debugging and other types of things. And then there's a hardware integration, which has to do with the actual sites and how the hardware will be deployed and integrated across the HPC facilities. So ExaWorks is a small part of a very large effort that's going on over 7 years. There are 3 years left in it. At the end of this 7-year project, there'll be multiple applications running at exascale on some of the first exascale computers in the world. And so we're a small effort, and the idea here is that we're the first workflow-focused effort in the ECP. So most of these projects have kicked off essentially on science teams. If they've partnered with workflow tools at the beginning, they're using them, but many of them are not. And so we're an important and timely project, and we're a phase 1 effort. I should mention that as well. We're basically sort of a feasibility study. Can we take another run at sharing software components and workflows and building, allowing scientists to build systems out of reusable components in a new way, rather than scientists potentially adopting monolithic applications. So essentially, workflows have largely been monolithically developed, and the deployment is oftentimes inefficient. Many teams are essentially building stuff out of shell scripts and Python pieces that they write, and it's not exactly maintainable. And so exascale is going to exacerbate this. Most of these teams are actually coupling together multiple independent applications. So there's a ton of issues there in scheduling those things. And we expect there to be success. So the interesting thing about workflows is that, if you throw enough students and you put enough effort at it, you can put something together with baling wire and duct tape, as it were, MacGyver something into working at scale. But to have this stuff be sustainable over the long term is one of the challenges. And so our project is essentially tackling this problem of the sustainability of these complex infrastructures that are being deployed and built by these science teams. And so our goals are to build a toolkit based on functional capabilities and found in many different systems. We want to directly impact the ECP. We're going to deploy and test these tools at DOE facilities. And a big part of what we're trying to do is actually build something, basically nucleate a sustainable toolkit. So oftentimes what happens is people will not adopt a particular tool because it's maybe flaky on one system and they need to run there, and it's not being tested well because the people that develop the tool aren't on that system all the time, right? And so we want to try to leverage the continuous integration capabilities the ECP is moving towards to actually sustainably test and validate these software packages against one another or together to enable people to have the confidence to adopt them. And so we're engaging the broader workflow tools communities as we go. In this phase 1 effort, we are primarily focused initially on some functional design across the component projects in our project, and then we're reaching out sort of in a targeted way towards some other parts of the workflow ecosystem. And so here on the right basically shows the 3 component technologies that we're nucleating around this toolkit is sort of being built out of the initial conversations across these three teams. And Parcel is one of them, as you see. The Radical Cyber Tools out of Shantanu Jha's group at Rutgers is another one. And then Flux is a hierarchical scheduler being developed at Lawrence Livermore Lab. And so that's going to be the next generation scheduler for our systems. So basically it will be the system scheduler that replaces Slurm at our site. So the idea is that these tools have components that stretch kind of horizontally across the workflow space, different capabilities, but also we have a vertical stack that we can target. So Flux is both a low-level scheduler, but it actually has APIs that are much more functional and pluggable than previous schedulers. And of course, Parcel and Radical have a ton of capability in sort of building complex integrated workflows and dealing with pilot jobs and all these capabilities. So the idea here is that we're instantiating a functional design group. We're going to look at how these different pieces might fit together and how we might start to find the API layers between them so that we can start to build towards these sort of pieces that people can adopt. And so the idea here is that our long-term goal is that these pieces get reused across the workflow tools community. So the workflow tools like Pegasus or Fireworks or any of the other tools that have the, similar capabilities within them. But we also have this goal of impacting the science teams that are building sort of the bespoke workflows. So we are working with teams that have not actually instantiated workflows yet, and they're still at the stage of Bash scripts and Python scripts and customized pieces. And we want to begin substituting some of these components into their workflow so they can start building on top of tested pieces rather than having each team essentially create a minimally functional like scheduler piece or a minimally functional orchestration piece and have to test that. So we're community focused. We're not attempting to replace, we're not a new workflow project. We're not building a new workflow system. We're starting with 3 concrete teams that we believe can integrate together, but the goal is to bring everybody else into this open source toolkit over the time. And we hope that with sustainable funding, we can do that. And this is a big problem space. So we're not also something like the MPI forum. We're not attempting to standardize everything for one time for everybody for all time. We're trying to find those sweet spots, the sort of 80-20 rule where we get a lot of benefit for some standardization without attempting to be all things to all people. So it's a sort of a balancing act that we're following, and we're discovering our path as we go. And so I will end there. I hope I kept everybody on time. And I'll just end with this slide, which is basically, you can look at it. We're targeting a lot of these workflow challenges. Not every team in ECP has workflow needs. Some of them are building very tightly coupled single application simulations that are going to run at massive scale. But many others are in fact coupling either simulations at multiple scales. So you'll have a continuum model coupled to like a lower scale model for subgrid scale type physics, or you'll have completely different codes being coupled together. And so those are the teams we're targeting where there's a lot of complexity in just scheduling their jobs and orchestrating them. Thanks. Any questions?
Yeah, thank you.
Hi, Dan, this is Doug.
Hey.
So so this is a very interesting project, but it sort of scratches an itch. And I know since Shantanu is on your team, I'm sure you've already gotten an earful about why workflow systems always get re-implemented. I think that something our community has not done well is to articulate what the hard problems in workflows are, right? So I think everybody feels like, oh, I can write a scheduler. What's the big deal? You put some stuff in order. And I think there are a lot of corner cases here that a lot of times people don't appreciate what the challenges are. So I'll give you my pet problem. My pet problem is that our execution systems are not very good at telling us when things are done, right? And this seems to be a problem that every single workflow system has. And if you go back to your picture, you had sort of your elements of things there. Yeah, I like that one. The big red X I want to put there is on the system schedulers. To say, gosh, if the system schedulers had an efficient way of telling us when stuff was done, that would solve a whole lot of problems way up in the stack. And I think there are all sorts of problems like this that don't rise to the fore because they seem way down in the weeds, but really they have a huge impact on the effectiveness of workflow systems. And I'm sorry, I guess that's a question, not a comment. I'll make it a question. Well, what do you think?
Yeah, no, I agree with that completely. And I'll point out that, I'm sure. So for example, the Flux system that's being developed is responding to some of these things. And so there are APIs for passing small messages around to enable orchestration that they're trying to build. And so the challenge there is to try to figure out where those APIs lay and stack with other similar capabilities and tools like Parcel and Ensemble Toolkit. But I would respond with one little anecdote. A year ago, I was working with multiple teams inside Lawrence Livermore Lab, and it turned out that neither our code teams nor these workflow efforts had actually agreed on or attempted to create a simple tool for determining when a simulation ended and the status it ended in. And so everybody had various weird methodologies. Some of them were very straightforward, like look for the word error or failure or seg fault, in the logs. But it was kind of funny that it's such a common thing and no one seemed to want to put any effort into it, yet it would solve so many problems to actually agree on that and test it properly. And so total agreement there that some of the stuff is more like low-hanging fruit, and there's not a lot of glory in it, right? But it's super useful for the community. And so one of the things I hope this project can do is maybe provide, at least to start at a place for people to plug in that done flag, the done record, essentially piece. But I thought it was kind of funny that no one had solved that problem because they didn't think it was a problem, right? They just had always gotten by. And I don't think you can get by on an exascale machine when there's a million jobs. I mean, the thing is that stuff all came out of a world where individual humans manipulated, dozens of simulations. But we're entering a world, even for non-complex workflows, where each individual user will essentially be doing a massive statistical experiment workflow where they'll spawn thousands of jobs and analyze the ensembles, not the individuals' runs anymore. So anyway, that's my piece of the soapbox, but I agree with you there.
I think if your project could highlight the points where friction causes blisters, that would be a great kind of.
That's a good way of putting it.
Right, and so I guess this may come up in the final talk that we're going to have that Raphael is going to give, but I'll mention that one of the other things that seems like a problem, and I don't know if you guys are addressing it or not, is the fact that workflows, the word workflow is conceptually different to different projects, even within the computational workflow kind of subfield, where workflows could have services, they could be programmed, they could be DAGs that are generated by some means outside, and then the workflow is just executing a DAG. I mean, there certainly are common elements, but they're pretty different as well in terms of how people think about them and how people address them. And I guess this picture, in particular, the fact that it has currently, I guess, 4 stacks, makes me wonder if that's something that you're going to be addressing and trying to come up with something that conceptually ties these things together, so we don't have 4 stacks that each have their own bottom layer and their own middle layer and their own top layer, but could have some better reuse of components across them, or use of components across them maybe.
Yeah, I think we're at the early stage, right? And so we're looking at pretty simple things right now, I would say, but even those things are actually complicated. I mean, how to specify a job and how to do that portably across systems is already kind of a pain. If you talk to the ECP folks, they have a CI system that they've got going at different sites, and they're trying to federate it all together so you can authenticate at your own site and then run tests at other sites. But even without that working, they haven't solved the problem of how you basically have to edit your CI, your GitLab CI YAML for each site individually based on the machines there. So we're tackling that problem first. But we've talked about the fact that, there are sort of 7 or 8 kind of components all workflow tools have. They all have some kind of graph representation of tasks, either implied or formal. And so I think there's hope that we might come up with a few implementations of each of those that the community comes up with that they might share. It would be, I just know that at Livermore, we have basically built new DAG packages inside Python a couple times now for internal workflow tools. And I always wonder, why why developers want to reinvent that. I think having, as someone who likes to program, I think it's fun to write a DAG, you know what I mean? Or it's fun to write a ray tracer. And so I know, and so I can kind of get that I can empathize with that. But honestly, the Los Alamos team has built a workflow tool called bflow. They just used a graph database for their DAG, right? And they put a thin layer over that. And so that seems like the right approach, right? Look for a good component, put a thin layer over it to satisfy what you need, and then move on with life and get on with the hard part. And so I hope our toolkit becomes that kind of a resource, right? Where you go there and there might be a few DAGs, there might be a couple different ways to orchestrate libraries that you can use to orchestrate tools. You know they're tested. You know that the DAG library and the orchestration library have been tested together on end systems, and so you can kind of reliably adopt them and try to build a system on top. So that's one vision, one part of the vision, because there's both the tool side, but there's also that sort of endless array, this endless sequence of science projects being started up by various funding agencies. They instantiate, they grow, they build a workflow, then they go off, and oftentimes the workflow goes fallow. And so those are the ones also we need to attack, because there's a lot of wasted effort there. People rebuilding the same thing over and over, year after year.
Right. I guess the part of the thing I was thinking about is the difference between workflows and data flows, right? And the fact that you can have pretty different models that can be called workflows in some ways. But
that's true. I would only comment that there's also a move towards the fact that the scheduler community and the HPC and the cloud community with Kubernetes and related technologies, those things are merging as well. And tools that aren't aware of that are going to become, have to play catch up when that stuff finally converges.
Right. Go ahead. The other question that I was going to ask is that I think it's great to have these projects working together on this. And if there are things that come out that are common, then I think that'll certainly be helpful for a lot of people. But there also are a wide variety of other scientific workflow systems that exist, and then a bunch of, let's say, more industry-oriented workflow systems that actually are pretty similar in a lot of ways. And so I guess I'm also just curious what your plans are in terms of reaching out beyond this group and into these kind of wider academic lab world, and then the wider industrial world.
So that's a good question. I think we're currently focused on the lab world because we're a phase one effort. We're trying to get full funding to complete, run with the rest of ECP to the end. I reached out to the Airflow community. That's an example of an outside data flow tool you might be aware of. It's a DAG tool. And, it's kind of hard to find out they're not really focused on HPC yet, and aside from HPC people trying them out, I haven't really seen that team so far look into the HPC world and say, we could be a player there. But they have a ton of resource, right, directed at them and a lot of complicated tools. But you also need a DevOps team to deploy that thing. And so the other piece of that is the mod sim community in the industrial area is moving really quickly towards cloud. And so I think for people that are doing finite element simulation and at Boeing and Raytheon and whatever, those people are going to be rapidly integrating with HPC in a completely different way than we do, and their tools are oftentimes not open. And so I'm not exactly sure how we're going to engage there, but it would be nice if those folks maybe adopted some of our capabilities over time. But I don't have a concrete, I don't think Kyle or Shantanu have, well, they might have thought about this as well. I've certainly thought about it because some teams at our labs, because we haven't, on the nuclear weapons side, we have a lot of manufacturing and capability. And a lot of our work ties science and manufacturing together. But we're not really using those kinds of outside tools yet that might be potentially useful. We have a lot of pilot projects and a certain amount of like product lifecycle management, but we haven't tied HPC to that stuff. And that's where I think a lot of interesting stuff might happen on the outside that we're going to have to look at. But we don't have a formal approach yet for tying that in. It's kind of outside of our scope at this point.
Okay, thank you. So we actually have some back channel discussion that has told me that I haven't been doing a very good job of keeping track of time, and I've been abusing my role as chair to ask too many questions. So let's go on.